Good evening, ma'am. Sir,
Good evening. How are you all?
fine, ma'am.
Good evening, ma'am. How
How are
are
you,
you?
Good
ma'am?
evening. Good evening. I'm also good. So these are revision classes for class 10th. When are you having your exams? Final exams.
Final exams from Feb 15th.
Okay.
Good evening, sir.
Good evening.
Good evening.
How many people generally join this revision session? Around around what number?
Mostly 10.
People in
Okay. Okay, so we'll start the revision session, okay?
Yes, ma'am.
So we'll learn about chapter carbon and its compounds. And I'll start from carbon compounds, that why why we see so many compounds having carbon in them. There are millions that we can't compare other elements with the elements of carbon, with the compounds of carbon. So why do we see these numbers? Anyone have any idea? Like it's written on the screen. Why do we have so many carbon compounds? It's because of mainly of these two properties, catenation and tetravalency. I'll suggest you can make these short notes. They'll help you revise before just a day before the exams. For example, if you'll write these short notes in 2 or 3 pages, and if you want to revise whole of the science chapter in a day. So these are some important definitions and important terms. So if you'll note them down, it will be helpful for you. Okay. So what is catenation? It is the ability of carbon to form bonds with other atom of carbon. You see carbon-carbon bond. We see carbon-carbon bond in rings also. Is there any other compound that can also form a bond with itself, like with carbon?
Silicon.
Yes,
Silicon.
but is it as reactive as carbon?
No, ma'am. It only forms 4 to 5 bonds.
It like the S8 atom you'll study in higher classes. Like silicon goes till sorry, that's sulfur. Yes, still it also forms till 8 atoms, around 8. Okay, but carbon can form around very high number.
Ma'am,
We
sulfur
don't.
can form
Yes,
8
sulfur can
bonds.
also form. Sulfur can also form S8.
Okay,
That
ma'am.
that you'll study in higher classes. But comparison to carbon, they are nowhere near carbon. Carbon can form carbon single bond, carbon carbon double bond, carbon carbon triple bond. So this is the property of catenation gives rise to large molecules of carbon. And then tetravalency. Tetravalency, tetra we mean four. That is, carbon has a valency of 4. Hence, it is capable of bonding with 4 other atoms. Carbon, it has 4 electrons in its valence set. So to complete its octets, how many electrons does it need? To complete its octet,
Eight.
More 4.
8. It already has 4.
Sorry,
So
ma'am.
how many more will it need? 4.
4 more.
That means it can form bonds with four other atoms. They can be either carbon-carbon, like this, or they can be carbon-hydrogen, or any other bond like carbon-halogen, like fluorine, chlorine, bromine.
Yes.
So this is the reason that carbon can form so many bonds. There another reason also, carbon has small size. What is the role of this small size of carbon in making so many bonds? Can anyone answer? Anyone have any idea?
Ma'am, can you repeat the question?
Why carbon being small in size helps in creating more number of bonds or strong bonds? Carbon has small size, that's why it forms stronger bonds. No idea?
No.
For
No.
example, this is carbon, and we take any other big element. Any other big element from the periodic table, anyone can suggest. In the periodic table, we have carbon, silicon, germanium. So, for example, we'll take germanium, and carbon is this size, and germanium is this size. This is carbon. It is positive charge. This is carbon atom we are drawing, and there are electrons around it. Then this is positive charge of germanium, and it is in big size, and there are electrons around it. This enables the carbon is small in size, and hence it enables the nucleus to hold on to the shared pair of electrons strongly. For example, hydrogen with its electron is coming, so it can approach its nucleus very closely. They'll form strong bonds. Now, hydrogen is coming for germanium. The distance is large. This attraction is less. Here, the attraction is more. So, when attraction is more, the bond will be stronger. So, is this clear or shall I repeat?
Ma'am, once can you repeat it again?
Okay. For example, here we have taken carbon, and here we have taken, for example, germanium. This is carbon is of smaller size, and this is of large size. Small size carbon, we have electrons here. Like any. For germanium, the number of electrons will be more, right?
Yes, ma'am.
Now, for example, hydrogen with its electron pair. This is hydrogen's electrons. It comes near carbon. This is the distance. There will be attraction between electron of hydrogen and nucleus of carbon. If hydrogen comes with electron from towards germanium, this is the distance. This is between positive, that is nucleus of germanium, and electron of hydrogen. Which distance is more? With the large size atom or
Germany.
with the small size atom?
Germanium.
Germanium has more distance between the nucleus and approaching electron. So the attraction will be less. Here attraction will be more. If the electrons, if this nucleus and this electron has more attraction, the bond will be stronger. Is this clear?
Yes, ma'am.
Okay.
Yes, ma'am.
So in exam, if you are asked why carbon has so many bonds, and you are asked the reason, the main two reasons are catenation and tetravalency, and why carbon makes stronger bonds. For that you will write that carbon has small size. This leads to nucleus holding shared pair of electron strongly. All of that I have explained, it can be written as the nucleus is holding the shared pair of electrons strongly. That's why the bonds are stronger. Okay. Now, the carbon compounds can be of two types: saturated carbon compounds and unsaturated carbon compounds. Okay, what do you mean by the general term saturation? That I have studied a lot today. This is my saturation point. I can't study anymore. Right?
Limitation.
That's yes. Further, we can't do anything. That is, this is carbon-carbon single bond, and there's hydrogen attached to it. This is carbon-carbon double bond, and then there's hydrogen. This is alkene, and this is alkane. The idea behind naming this was, if we want to add, for example, H2 to it, can H2 add anywhere? There's no space. But if we want to add H2 to alkene, this bond can break and we can add H2 here. It has the capacity to add. The unsaturated carbon compounds for definition, you'll remember the simple definition that saturated carbon compounds are the compounds where the carbon-carbon atom are linked with a single bond. The carbon-carbon, no, don't say that here C and H is a single bond, here also C and H is single bond. Don't see these bonds. The carbon-carbon bond. If we find carbon-carbon single bond everywhere throughout the molecule, it's a saturated carbon compound. But if in this carbon compound we get double bond anywhere, that is, we can now add something to it, right? It has become unsaturated carbon compound. So if carbon compound have any double bond or triple bond between the carbon atoms, then it will be unsaturated. Clear? Is this clear? Difference between saturated and unsaturated carbon compounds.
Yes, ma'am.
Benzene is an
Yes, ma'am.
example of saturated or unsaturated carbon compound. Benzene. This is benzene. Can you see double
Yes,
bond
ma'am.
or
Ma'am,
only single bond?
unsaturated.
Unsaturated.
Yes. So
Ma'am, it
benzene
is
is an example of,
unsaturated.
yes, unsaturated carbon compound. So in exam, if you are asked difference between saturated and unsaturated, write this definition that they are linked by single bond, they are linked by double bond or triple bond. And then here you can give example. For example, this. This is also unsaturated. This is also saturated, sorry. Here we don't see any double bond. Though we don't see CC bond also, but there's no double bond. That's why it's saturated compound. That's why saturated carbon compound, at least it has one carbon. So this methane and then ethane with two carbon. It is also saturated carbon compound. You can give these two examples. And then for unsaturated, you give this example of this alkene or this alkyne. Okay.
Yes, ma'am.
Now, if I take example of butane, a number of carbons in butane, anyone can answer. Number of carbons in butane,
4.
4.
4. So we'll link them like this, 4 carbons, and then we'll put hydrogen. Is this the only way we can arrange these carbons?
No, ma'am.
No, ma'am.
There's another way also, like this. And then we'll put hydrogen. But when we'll calculate the formula, what will it come out? C4, H4, 4, 8, 9, and 10. Here, C, 1, 2, 3, 4. And number of hydrogen, 6, 9, and
Third.
10. The molecular formula comes out same.
Yes, ma'am.
But the structures are different. What do we call them? Structural isomers. So the compounds with identical molecular formula, like here we see C4H10, C4H10, but different structures. Here we see straight CC bond, here we see CC bond arranged in this way. These are structural isomers. So these compounds, both of them, they are structural isomers of each other. Is it clear?
Yes, ma'am.
Yes, ma'am.
Now, what do we mean by hydrocarbon? We can see it in the name itself. Hydro for hydrogen and carbons. That is, all the carbon compounds which contain only carbon and hydrogen. These are called hydrocarbons. These are important definitions I am stating out for you. You can note them or write the keywords like hydrocarbons. Out of these, the saturated hydrocarbons, like for example this, it is there is no double bond or single bond. This is known as alkane. I'll draw this for you. You can also draw in your notebooks. Hydrocarbons, they can be alkanes, they can be alkenes, or they can be alkynes. Alkenes are alkanes are saturated. Alkenes which contains double bonds. The double bonds can be of any number of double bonds. This is unsaturated. And alkynes when there is triple bond. This is also
Unsaturated.
unsaturated. So simple if we are asked that what are hydrocarbons and what are the types of hydrocarbons. So hydrocarbons are the compounds which contain only carbon and hydrogen, and there can be 3 types of hydrocarbons. First alkanes, second alkenes, and third alkynes, and we will give examples and we'll tell which one is saturated and which one is unsaturated. Do you all know the concept of functional groups? Can you give me some example of any functional group?
Alcohol,
Aldehyde.
Yes,
aldehyde,
Carboxylic
aldehyde.
ketone,
acid.
carboxylic acid,
Yes.
Ketone.
Why are we calling them functional group?
and halogen.
Okay, yes, these are all correct. These are functional groups because they assign, they give some property to a normal alkane, alkene, or alkyne compounds. For example, this was a simple alkane. Now we replace it with one hydrogen with OH group. This has become an alcohol now. It has become alcohol because of this OH group. That is, its property has changed. It may not have dissolved in water, but this will dissolve in water because it has OH group. I'm giving this
Ethanoic acid
example that how
also is.
property changes. Yes,
Can ethanoic acid also come in the
ethanoic acid. Yes, asking of ethanoic acid. Ethanoic acid will also have this group, na?
okay, ma'am.
There's this group present. If this group is present, you are already saying in the name itself that it's acid. How it is acid? How we came to know about that it is acid? It's acid because this is the function of that compound. This is the property of that compound. It has that functional group that is COOH. That's why we are calling it acid. We can't call this as acid, right? Especially the carboxylic acid. So all of these compounds, these functional groups, whether it's halogen may you know that it's fluorine, chlorine, bromine, iodine. These are all halogens. Okay. And then with oxygen, what class of functional groups we can form? Alcohol, that is OH, aldehyde, that is COH, ketone, for example, this ketone, where these are like R group, any alkyl group. Any group can be there, but they will have CO in the middle. And then carboxylic group will have, for example, CH3, CH2, COH. Here we have replaced CH3, CH3, one H with this group. So the functional groups are here alcohol, aldehyde, ketone, and carboxylic acid or halogen. So if we are asked what is functional group, so functional groups have heteroatoms. Heteroatoms are which atoms? Atoms other than carbon or hydrogen. For example, this is simple alkane. If we add any other atom other than them, out of these, chlorine, bromine, or iodine, or any oxygen atom, these are heteroatoms. And we add this to, or we replace any hydrogen with these heteroatoms. So they add some property to these compounds. And hence, these are called functional groups. Everyone clear? This
Yes, ma'am.
any element which replaces hydrogen is the heteroatom. Okay. So we'll now study about some important concept that is homologous series. Homologous series, I'll read out this definition. It is a series of compound where the same functional group substitutes for hydrogen in a carbon chain. If we want to understand this, for example, these are alkenes I am writing. You know this concept. Have been taught this, that this is the general formula for alkene. alkane, alkene, and alkyne. Have you been taught this?
Yes, ma'am.
Yes, ma'am.
Okay. So from that I wrote this series of alkane. If we subtract C2H6 minus CH4, what will be the unit we are adding? We'll get the unit we are adding. 2 hydrogen and 1. That means we added CH2. Now from C3H8, if we'll subtract C2H6, we'll again get CH2. So this is this series of compound, same functional group substitutes. CH2 is the functional group we are substituting in place of hydrogen in a carbon chain. So this is same, right? We are adding CH2 and CH2. So this becomes a homologous series. Everyone clear that what is homologous series?
Yes, ma'am. Yes,
Okay.
ma'am.
So, for example, I write, is this a homologous series?
Yes, ma'am. It is homologous series.
Why?
Ma'am,
What
because
is this? Yes,
CH2 is adding in every compound.
yes. So same functional group is getting added to move on to the next number. So this series is also an example of homologous series. So if you are asked that what is homologous series and explain it with the help of examples, so you can give example and use this definition also. Okay, is it clear for everyone?
Yes, ma'am.
Now,
Yes, ma'am.
some properties why we are studying this homologous series, that what happens when we move from an alkane of lower mass to an alkane of higher mass. For example, this is methane and this is propane. Which of them will melt at higher temperature? Which of them will melt at higher temperature? Methane or propane? Anyone? Just tell me methane or propane.
Propane.
Yes. Why propane will melt at higher temperature? Because the mass has increased. More amount will require more temperature to melt. Okay. So this explains us the concept that molecular mass increases in homologous series. We are moving from methane to propane. There is increase in molecular mass. So we'll see change in physical properties. What is the example of physical properties? Physical properties, for example, melting point, boiling point, or solubility. All of this will be affected when we move from one end to another in homologous series. But the chemical properties, that how they react, how methane reacts, how propane reacts, how methanol reacts, how propanol reacts, how methanol or propanol reacts. Is this change in this number of carbons, is this going to affect the chemical reactions? No. This is solely by the functional group. The chemical reactions, because they happen mostly with the functional group only, so they are determined by the functional group. With molecular mass increase in homologous series, physical properties change, but the chemical properties, they are determined by the functional group. They remain similar in homologous series. Okay, I'm explaining this key concept. You can have a question in exam like this, that whether physical property changes with molecular mass in homologous series or chemical properties. Can you answer that now? Now, you must have learned nomenclature, how we name these compounds. First of all, all of you must remember this, that if it's one carbon, then it's methane. If it's two carbon, then it's ethane. If it's three carbon, then it's propane. Then
butane,
butane. Then pentane
pentane,
for five carbon,
hexane.
hexane for six carbon. So this should be handy. You should always remember this, because on basis of these numbers only you will be able to name the carbon compounds. Because the first step in the nomenclature of carbon compounds is identifying the number of carbon atoms. When you identify the number of carbon atoms, on the basis of that, you are going to name further. For example, if there are three carbon atoms, you'll simply say propane. If there's no other group, like no double bond or no functional group, so you'll simply say propane. But if it has some functional group, so you will either add a prefix or a suffix. You must know about prefix or suffix. Prefix is added before and suffix is added after. For example, you'll remember this, that for haloalkenes, that is for chlorine, bromine, fluorine, iodine, we'll add prefix. For example, to propane, we had this whole propane. But we replace this hydrogen with chlorine. The rest of we have three carbons, therefore we'll say this is propane. But we have chlorine also. So we'll add prefix for chlorine, that it is chloropropane. Okay. For example, what is the name of this compound? Anyone?
Ma'am, is it bromo? Uh,
Ma'am,
Three carbons.
one bromo, one one bromo
One bromopropane.
propane, one bromo propane.
Okay. So you'll have to remember this.
Bromopropane,
Okay. And this one?
One
bromo,
bromo hexane. Sorry, no, no, ethane.
bromomethane.
Ethane. Bromoethane. So clear how to name with halogens. Now, if we are taking another functional groups, all for alcohols. For rest of them, we'll add them as suffix. So remember this, for alcohol, the suffix will be ol. For aldehyde, the suffix will be al. For ketone, the suffix will be on. For carboxylic acid, the suffix will be oic acid. For alkenes, it's -ene. For alkynes, it's -ine. So this suffix that we have to add is hidden in the name itself. For example, from alcohol, the last two letters, all. From aldehyde, the first two letters, L. And from ketone, on. From carboxylic acid, it's oic acid. From alkenes, it's -ene. And from alkynes, it's -ine. All of them will be added as suffix. Only for halo, that is fluorine, chlorine, bromine, iodine, if they are functional group, then we'll add prefix. But for rest of the functional groups, we'll add them as suffix. Then moving on to the next rule. For example, if we have given a suffix that we have to add something at the end of the word. If the suffix of the functional group begins with a vowel, that is A, I, O, U, then the name of the carbon chain is modified by deleting the finally. All the carbon chain, the name we are seeing, for example, methane, ethane, propane, butane, pentane, or hexane, all of them has E at their end, right? And for example,
Yes.
we have to add the suffix ol for alcohol. O is a vowel or not?
Yes.
O is a vowel, right? So this rule will be applied. For example, we have to add ol to hexane. We have this compound. We have 6 carbon and 1 OH group to it, and rest of them with hydrogen. Okay. So we have to name this. We'll write that this is hexane, plus we'll have to add suffix for this functional group, and suffix for alcohol is OL. But now we see that OL has O. That is, this is a vowel. So the rule is we have to delete the final E in the name of the carbon chain. We'll subtract E from this, and then we'll write hexanol. So this will be the name for this compound. Understood? So all of them has a vowel except, so this A, O, if we have to add this ol, L, on, we'll have to remove the end E. For example, I'll give you example. You'll have to tell me that what you'll name it as. First of all, tell me which functional group is this?
Ketone.
Is it ketone?
Yes, ma'am.
Opposite.
Isn't it aldehyde?
Yes, ma'am. It's aldehyde.
So this is aldehyde. What is this functional group?
Ketone.
This is ketone. There are alkyl groups on its both sides. There is hydrogen in on its one side. Then it will be aldehyde. So don't get confused between ketone or aldehyde, okay? Now we see the number of carbons in this. How many number of carbon are there?
6.
3. There are 3 carbons. So what is the name of the carbon atoms then we'll use? Methane, ethane, propane, butane.
Propane.
It will be propene. And what is the suffix for aldehyde?
Al.
Yes. So, handwriting the name as,
Propanol.
is it correct?
E should be
Yes. We'll have to eliminate E because the suffix has A in it, and A is a vowel. So, the correct name will be propanol. So, we are done with 3 rules. The next is if carbon chain is unsaturated, then the final ane in the name of the chain is substituted by ane or ine. For example, this is simply ethane. Now, what will be its name on basis of this rule? What will be the name of this compound?
Ethene.
Anyone? Yes. So everyone clear with the rules?
Yes, ma'am.
So you can name these organic compounds any one of you, right? Every one of you can name these compounds. So you have any class after this?
Yes, ma'am.
At what time?
7:20.
Okay, I was asked to take this class till 6:50 only. So okay, we'll start with chemical properties in next class. If we'll get any next class, if I'll get any class with you. So did you enjoy this class, the revision part?
Yes, ma'am.
Okay. Any doubts?
Not, ma'am.
Anything new you learned in this class? Anything?
Ma'am, according to me, the distance property which you have said, the small size and the big size.
Okay, okay. How small size leads to stronger bones.
Yes,
Okay.
ma'am.
See, which book do you follow for science in class 10?
NCRT.
NCRT
NCERT.
only. So this is given in NCRT only. That's why it said that read every line of NCRT carefully.
Marian.
I'm not teaching from anywhere else. I'm teaching from NCRT only. And it's given clearly in NCRT. Okay. That's why before going for multiple books, read the basic book that CBSE or any other board follows again and again. Then only you'll understand the book in depth. Okay.
Yes, ma'am. Can you share this PDF?
This PDF, okay, I'll share. Okay. So we shall end the class now. Thank you, everyone.
Thank you, bro.
Thank
Bye.
you.
Thank you, ma'am.